Why is it so much hotter above a pot of boiling water than next to it? How does the sun get all that heat to us when there's no air in space? Why is it that if I put my hand near some ice, it doesn't feel cold at all, but as soon as I touch the ice, it's really, really cold? And how does my vacuum flask keep my hot chocolate warm all day? Welcome to Flip Physics. Today I'm going to talk about heat transfer. We've already said that heat is a type of energy measured in joules. Heat transfers when particles from a higher temperature object hit particles from a lower temperature object. As the particles hit each other, the energy spreads out, and so the temperature of the colder object increases and the temperature of the hotter object decreases. But if heat transfers like that, then how do we get energy from the sun? There are hardly any particles between us and the sun. There must be more to this picture. There are three main ways that heat can transfer from a hotter object to a colder object. The first is the process that most closely matches what I just described. It's called conduction. As soon as I touched the metal, there was direct contact between my hand and the colder metal, and that caused the particles to hit each other and the heat to spread out from my hand into the cold metal. But that doesn't explain why, for example, it's hotter when you hold your hand above a flame as opposed to next to it. If it was as simple as touch, when I was touching the flame, I would feel the heat. When I wasn't, I wouldn't feel much. Or maybe it would be about the distance I was away from the flame. With this situation, something else is happening. The molecules are actually moving around wholesale. This is called convection. Hotter molecules tend to rise, whereas colder molecules tend to sink. As the water in this pot is heated, the water near the bottom is heated the most. As we heat the water, the particles start to move a little bit further apart. That makes them less dense, and less dense things, just like a cork in some water, will bob towards the top. So the hot water rises and cools as it goes up, causing it to become denser again, and then it sinks, and then the process just repeats and repeats. These are called convection currents. So convection is another type of heat transfer, but there are basically no molecules at all in space. So how does that work? Why is the Earth not a frozen wasteland? Damn you, vacuum of space, stopping heat transfer and causing my entire existence to be impossible. That's because of a third type of heat transfer called radiation. Electromagnetic waves, such as light or infrared or radio waves, all those types of electromagnetic waves are forms of radiation. They radiate. Those waves of radiation can carry energy, and so we get infrared and light from the sun, and this brings energy with it. And these types of electromagnetic waves can even move in a vacuum. And as those waves reach the Earth, they're then absorbed. That heat is absorbed by us, or the ground, or the air. So here's a question for you. With your newfound knowledge of heat transfers, how is it that an expensive vacuum flask keeps my hot chocolate warm? Well, first we have the vacuum layer. The clue there was in the name. The vacuum stops conduction because there's no material in that layer to carry the vibrations and collisions. There are no molecules to collide with each other. Second, there's the heavily insulated lid. That stops convection. It stops heat rising and escaping through the top. And last of all, there's its shiny mirrored surface. That stops radiation. Just like light bounces off a mirror to enable you to see yourself, all radiation will tend to bounce off shiny things. All these things work together to keep my hot chocolate nice and warm. It's not perfect, but in weather like this, it does the job. Thanks for watching Flip Physics. If you like this video, feel free to press the like button. You can also subscribe or go to the flipphysics.net website. But most of all, don't forget to leave a comment below with your questions, thoughts and suggestions. Till next time, keep questioning. At last I see the light.